All right, good morning, everybody. Okay, so picking up from where we left off last day. So in a Python program, you can put in comments, and the comments in Python, they always begin with a hashtag. Right? And so in Python, the hashtag marks the beginning of the line-ending comment. Right? So hashtag here, anything after the hashtag is ignored. Right? And so that's a comment. That line there is a comment. Right? That line there. So you have a line of code, and then you can end it with a comment, right? And so anything after the hashtag is just ignored. So you can't place a comment in Python between, or on a single line between pieces of text. So I'll show you what that means in just a second. Right? So in Java, an inline or end-lining comment ends with a double forward slash. Right? So 2 forward slashes, that's the equivalent comment delimiter relative to Python in Java. But Java has a second type of comment delimiter as well, right? And so you can have a multi-line comment in Java. So a multi-line comment in Java starts with /*, and it ends with the next */. Right? So /* marks the comment. Now everything up until the next */ is part of the comment. Right? And this means that you can insert a comment into the middle of a line or between 2 lines of code. Right? So here, right, I can declare a variable, right, put the equal sign or the assignment operator in, and then I can stick in, this type of comment here. Right? And then I can finish off the line of code here, and I can even put another comment after that line of code there. And so the multi-line comment is something that Python doesn't really have. Right? You guys might have, someone might have told you that you can use a triple quoted string as a multi-line comment. That's not precisely true in Python. There are times when that doesn't work. But in Java, the multi-line comment always works. Right? So /* ends with the next */. So Python has an exponentiation operator, right? So ** in Python does x ** y does x to the power y. You can't do that in Java. So Java only has addition, subtraction, multiplication, division, and remainder, plus some other binary operators that we don't need to worry about right now. If you want exponentiation, you have to call a method in Java to do so. Right? And so in Java, you have to call this method that's called pow, right? And it's a little bit unusual in that you have to stick in the word math in front of it. Right? So it's big M math dot POW, and then that's your base, that's your exponent, right? So that computes 1 plus r raised to the power 10. Right? Math is the name of a class, so it's the name of a class in Java that contains a bunch of methods and constants related to mathematical operations. So I'm just going to pop open a web browser somewhere and quickly show you what this looks like. So if you're ever looking for documentation on a class in Java, the easiest way to do it, if you haven't memorized the URL for it, is to just type in Java, pick a version number, like 8 or 20 or something, right? And then type in the name of the class that you're looking for. So I'm looking for the math class, right? That almost always works. It's almost always the first match, right? Click on that. And so Java's documentation is all online. It looks quite different than the standard Python documentation. In my opinion, the Java documentation is easier to read, but you may think otherwise. So this is the documentation for the math class, right? There's a description of what the math class is for up here, right? If you scroll through, right, you'll eventually come to this section here. It's called the field summaries. You'll see that there's something called e and something called pi, right? They're both of type double. So these are just the constants that represent the Euler's number, so e in math. And pi, right? The ratio of a circumference of a circle to its diameter. Right? So to use e and pi, you write math.e and math.pi if you want them. And then there's a bunch of methods. Right? And so if you scroll through here, you can find the power method. Right? It's alphabetized. Notice there's a lot of methods. Where to go? Pow, there it is. Right? And so there's pow. And if you click on pow, it takes you to the detailed description of the method. Right? So pow tells you that it returns a double, right? It takes in a value A and a value B that are also both doubles. And then it computes the first argument, so a, raised to the power of the second argument, right? So a raised to the power b. And then there's a bunch of special cases where it may or may not work. There's a lot of them, actually. Look at that. Right? Okay, so there's how you can find the description for methods in Java. All right, so in Python, variables don't have types, but objects do have types. Right? So the word big T true corresponds to a Python object that represents logical true, right? And big F false is logical false. Right? 1 actually corresponds to an object in Python that represents an integer value 1. Right? It's not the number 1, right? In Python. In Python, this actually corresponds to an object. Right? 1.0 corresponds to a Python object that represents the floating point number 1.0. Right? So floating point meaning it has a decimal point in it, possibly followed by some other digits. Right? So this looks like a real number in math. Single, double, or triple quoted strings. Single, double, or triple quoted sequences of characters are strings in Java. In Python, that's actually str, not string. Right? In Python, the type is str. And that's an empty list in Python. Right? And so these things on the right-hand side of the equal sign, these are called literals. Right? The literals are values that you can actually write down. Right? So true and false, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those are all literals. Right? 1.0, 1.1, and so on and so on and so forth. Right? So in Java, the corresponding literals are as follows. The corresponding literals and their types, right? So it's not big T true, it's little t true in Java, right? All variables need a type in Java, so the type that you associate with TF is Boolean, right? 1, just like Python, is an int, right? So I need a variable to hold that value. I want a variable in this case to hold that value, so it's going to be of type int, right? If you have a floating point number, so something that looks like a real number, typically you choose double. Strings in Java are big S string, and there are no list literals in Java, right? So there's no nice, simple way to create a list like you can in Python. So you can't write square bracket in Java, right? Instead, you have to do this, what looks strange to a Python programmer, right? You have to write something like new and then some other type here, followed by some round brackets. Right? And so we'll get to this later on, right? For now, just realize that there are no list literals in Java. And using a list is slightly harder in Java than it is in Python. Okay, so in Python, everything is a reference type, I don't know if they told you this or not, right? But every type that you use in Python is what's called a reference type. They all refer to objects, right? So values in Python are actually what are called references to objects. And I'll explain what a reference is shortly. Right, so back here on this slide, right, true, 1, 1.0, hello, and the empty list, those are all actually objects. Right? So Java also has these things called reference types. Right? So in other words, Java also has objects. Right? You can tell what is a reference type in Java by its type name. Right? And so if the type name begins with a capital letter, it's a reference type. Right? So big S string, reference type. Right? Big L list, reference type. Big A array list, reference type. Right? So in Java, Java and Python, reference types are represented with classes. Right? So a class is just a user-defined reference type. Right? If you want to make up your own type in either language, you just create a class. Right? When you create the class, that creates a new type, right? And it happens to always be a reference type in both languages. Java also has these things called primitive types, which Python does not have. Right? So anything that begins with a lowercase letter, or any type that begins with a lowercase letter, is a primitive type. Right? Boolean, primitive. Right? Little I int, primitive. Little d double, primitive. Those are all primitive types. Right? Right? So this is why the convention exists that when you create a class, you always give it an uppercase letter name. Right? Because Java programmers are used to seeing, if they see something, a type that's in uppercase, they're used to thinking that it's a reference type. And if they see something that's in lowercase, they're used to thinking that it's a primitive type. Right? And the difference between a primitive type and a reference type is significant in Java. Right? So I'm going to explain what the differences are shortly. Right? You have exactly 8 primitive types in Java. Right? So Boolean, true and false. All of these are actually integer types. Right? So byte, char, short, int, and long are your primitive integer types. Float and double are your floating point, your real number types in Java. Right? In Python, the floating point type is called float, right? Which is confusing because the exact same type in Java is called double. Right? So we'll get to that. Hopefully at the end of this lecture, but it might be the next lecture. Okay, so the important types for us right now are Boolean, int, and double. Right? Eventually we'll get to char. I'll explain what the and long and float will also be mentioned. Okay. All right, so what is this difference between a reference type and a primitive type? Okay, so references, reference variables store what are called references to objects. Right? So all variables in Python store references. Right? So x equals 1. Right? The variable x is storing a reference to an int object whose value is 1. Right? Y equals 1.0 means y is storing a reference to a float object whose value is 1.0. And s equals hello means that s is storing a reference to a str object, so that's the string type in Python, whose characters are H, E, L, L, and O. Right? Okay, so what's a reference? Right? So a reference is a way for the computer to find that object in memory. Right? So in Python, the number 1, it actually corresponds to some object whose type is int. Right? Inside that object, there's some variable, there's some piece of data that has the value 1, and there's a bunch of other stuff, right, that lets Python be able to interpret that number as an integer type and do various things like addition, subtraction, less than, greater than, and so on and so on and so forth. Right? So there's a bunch of stuff that's actually associated with this number 1. Right? When you write x equals 1, the object is not stored in the variable x. Right? The object is stored somewhere else in memory. Right? It doesn't matter where, right? It's somewhere else. Right? And so the value that's stored with x is just some value that lets the computer figure out, okay, where in memory is this object? Right? And so, for example, it might be the address of the object in memory. Right? Exactly how it does it, it doesn't matter. Right? But it's not the object itself that's stored with the value. Right? It's something called a reference. A reference is just some value that lets the computer figure out where is this object in memory. So Python doesn't have primitive types, but Java does. Right? So a primitive type variable actually stores a value, right? The value of the primitive type. So when you write x equals 1, right, the way you should think about this is that somewhere in memory there's a box labeled x. Right? Beside that box is the number 1. Right? Y equals 1.0 means somewhere in memory there's a box labeled y. Right? Beside that box is the value 1.0. Right? Now here we've got a reference type, right? Big S string, so that's a reference type. Right? S equals, and then on the right-hand side there's a string object here. Right? And so the way you should think about this is that somewhere in memory there's a box labeled S. Right? Beside the box labeled S is some value that lets it figure out where this object is. Right? Somewhere else in memory there's actually a box, there's some other box or boxes that contain the object corresponding to the string hello, right? And whatever happens to be in that string object, right? I don't actually know what's there. I've never looked at the I've never looked at the implementation of a string class in Java, right? So primitive types, they hold the actual value, right? X equals 1, the value associated with x is 1, right? Reference type, S equals hello, right? So S is a string reference, right? The value that it holds is something that lets it figure out where this object is in memory. All right, so the primitive, any questions about, yes?
Just double checking, is the object just an instance of a class?
An object is exactly an instance of a class, yes. Any other questions? All right. So the primitive types. So a primitive type object in, sorry, not a primitive type object. So primitive type values occupy in Java a defined fixed amount of memory, right? So Java says an int is exactly so big, right, or takes up exactly so much memory. A double takes up exactly so much memory, and so on and so on and so forth, right? The amount of memory is fixed, so it's finite, right? And so what that means is you can only represent a finite number of values when you're using a primitive type, right? The amount of memory is finite, so there's no way that you can represent an infinite value, right? So you have, or an infinite number of values, right? So this has all sorts of weird implications in Java, right? It has some in Python, but you probably never saw them, right? Okay, so if every primitive type represents a finite number of values, right? What does that mean? It means that when you use int, right, there's some maximum value that you can represent, and there is some minimum value you can represent, and anything outside of that range you cannot represent, right? So for int, the most negative value that you can write down is roughly minus 2 billion. Right? The largest value that you can write down is roughly 2 billion. Right? Notice that they're not exactly symmetric about 0. Right? That's an 8, that's a 7. If you want a value that's smaller than this value here, right, you can't use int to represent it. Right? If you want a value that's bigger than that value there, you cannot use int to represent it. Right? You must use some other type. Question?
Does this imply that you could change the low and high in ints?
No, they're fixed. The amount of memory that an int occupies is fixed by the language. The representation of an int is fixed by the language.
So, like, could you change what the minimum and maximum is? Like, could I have the minimum be plus 10 and the maximum be plus 10 for an int?
No. Sorry, so so using the int type on its own, the answer is no. But you can make your own type where that is true.
Yeah, that would be
Yes, so yes, you can create a type that represents a range of values where you can specify what you want the minimum and maximum value to be. Yes?
Okay, so you could modify ints to have.
You can't modify int to do that.
You
have to make your own type, and your own type has to build in all of the logic required to put those restrictions in.
I can't make a subclass of int that has a different minimum.
No, int's not a class. Int is a primitive type, so you cannot create a subclass of int.
Okay.
Yeah, that doesn't work in Java. All right, so if you write down a number in Java, right, that has no decimal place in it, so like -1 or 99 or 98, right, as far as the Java compiler is concerned, that is an int literal. Right? So you write down a number, no decimal place, it's an int. Right? So -1 is an int, 99 is an int, 0 is an int. Right? The type long is also an integer type, right? But it represents a wider range of values than int. Right? So its minimum value is much larger in magnitude than the minimum value of int. Its maximum value is much larger in magnitude than the maximum value of int. Right? If you want to write down a long literal, you write down your number and then you stick an L after it. Right? You should use big L because the little l looks like a 1. Right? So -1 big L would be a long literal. Right? 99 big L would be a long literal. Right? If there's no L and there's no decimal point, it's an int literal. If you want to, you can put in underscores between the digits to make it easier to read. Right? You don't have to, but you are allowed. Right? If you happen to know what binary, octal, and hexadecimal are, there are ways to write down those integer values in Java, but it's not relevant to this course. Right? If you want to know how to do it, just look it up. Right? So it is possible to write down a binary number in Java. It is possible to write down octal and hexadecimal as well. Right? That's just base 2, base 8, and base 16 if you don't know what those are. Okay, so there are some big differences between how integers work in Java compared to how they work in Python. Right? So if you do an operation with 2 int values, add, subtract, divide, multiply, remainder, right? The result is always another int value. Right? That includes division. Right? So if you divide 2 ints, mathematically, you usually get a real number, right? In Java, you get an integer number. And the way it works in Java is you do the division and then you throw away everything after the decimal point. Right? So I'll explain that in just a second. Right? So here we've got 1, 3, and 13. Right? If I add 1 and 3, obviously you get 4. Right? Subtract 1 and 3, obviously you get -2. Right? Now, if I take 1 and 3 and divide them, right? So 1 divided by 3, so mathematically that's 0.33333, right? You throw away the 0.33333. So that gives you 0.
So no rounding?
No rounding. It's called truncating division. Throw away the fractional part, right? You throw away everything after the decimal point. Right? So z divided by y, so that's 13 divided by 3, right? Which is 4.33333. Throw away the 0.33333, and you get 4. Right? If that was minus 13, it's the same thing, right? So minus 13 divided by 3, minus 4.33333, throw away everything after the decimal point, and you get -4. Right? Of course, you get brackets as well. You get parentheses in Java. You cannot use the square brackets and the braces, right? Just like you can't do in Python, right? So if you want parentheses, it's always the round brackets, right? And those work the same way as they do in math, right? They just, they force whatever's inside parentheses to happen first. Okay, so that's a big difference, right? So in Python, if you take 2 integer values and divide them, you get a float, right? So 1 divided by 3 in Python gives you 0.33333 as a floating point number. Right? Unless you use // right? So // in Python is Python's integer division operator. It's slightly different than Java's integer division operator, right? Okay, so what happened? Okay, so notice this sentence here, right? So this sentence here says an operation involving 2 ints always results in an int. Okay, so so that means that you can easily take 2 ints, perform some operation on them, addition, subtraction, whatever, right? And the result will be outside the range of int, right? So for example, I can take integer max value and try to add 1 to it, right? I can't represent x plus 1 using an int, right? But the language says x plus 1, whatever that result is, the result will also be an int, right? So that's an int, right? X is an int right here, right? 1 is an int literal, right? So that's an int plus an int. So Java says I'm going to do integer math with this, or int arithmetic with this. So x plus 1 becomes, what does it become? So what happens is you start out at integer max value, right? So here's integer max value over here. Here's integer min value over here, right? You start out over here, you add 1, you wrap all the way around to the other side, right? So the value wraps to the other end of the range, right? So if I start at max value, add 1, you end up at integer min value, which is bizarre, right? Positive number plus a positive number results in a negative number, right? Strange, but true. Right? So arithmetic on your computer is not the same as arithmetic in math, right? They don't follow the same rules. What's x plus 2? So I start out at max value. If I add 1, I end up at min value. So x plus 2 is like x plus 1 plus 1, right? So I end up at min value, and then I add 1, right? X plus 3 is like x plus 1 plus 1 plus 1, right? So I end up at min value, then I add 1, then I add 1 more. Right? So I end up at integer min value plus 2. Right? So the same thing happens on the other end. Right? So if I have, if an operation results in a value that is less than integer min value, it just wraps around to the other side. Right? So if I start out at integer min value, right? So minus 2 billion roughly, and subtract 1, so a negative value minus a positive value, you end up at integer max value, which is a positive value, right? Again, does not make sense mathematically, but that's the way it works on your computer, right? So x minus 2, so start at integer min value, wrap around to max value, and then subtract 1, right? So you're at integer max value minus 1. X minus 3, wrap around, right, to integer min value, and then subtract 2. This may seem strange, but this happens in a lot of languages. Right? So all of the C-like languages in particular, this happens. So C, it happens, C++, it happens in C#, it happens in the predecessors of the C language, it happens in Java. Right? This phenomenon is called integer overflow. Right? So this occurs when an arithmetic calculation with an integer type results in a value that is outside the range that the type can hold. Right? So depending on the language, different things happen. So the C-like languages, wrapping always occurs. Right? So if you exceed the maximum value, it goes around to the minimum value, right? And then continues the operation. Right? If you go past the minimum value, it goes around to the maximum value and then continues the operation. If you're in some other language, so like Python, for example, this doesn't happen at all, right? The result is no longer an int, it results in a floating point type. So if you're dividing, the result ends up in a floating point type. If you're doing addition or subtraction or multiplication in Python, right? Python's int type has no built-in minimum and maximum value, right? And so it can keep on going. Right? So for example, you can compute a Google in Python, right? 10 raised to the power of 100 without any issues whatsoever. Right? The reason you can do this in Python is because in Python, integers they're actually objects. Right? And so you can you can design the class that represents int in Python so that it has no built-in maximum or minimum value. Right? The price you pay is that using an int in Python is much slower than using an int in Java or one of these other languages where it's actually a primitive type. Yeah, question?
Sorry, two questions. First of all, does that also mean that Python will use more space? Or?
Yeah, so if there is no built-in minimum and maximum value, Python still needs a way to represent all the digits in your number. So it needs to allocate memory, enough memory to allocate all those digits in that number.
Just double checking, is overflow a software or like the circuits themselves change over the years?
So it's both. It's technically both. So if you ask your computer to perform an integer operation, right? Your computer, the hardware in your computer has a fixed it's called a fixed word size, right? So the number of bits that it can operate on at once is fixed, right? On most of your modern computers, it's 64 bits, right? But you can extend, your particular CPU might be able to extend that to 128 or something else. But whatever it is, it's finite and it's fixed, right? So there is, when you do an int operation in Java, right? The resulting code causes that operation to happen on your processor. It causes it to happen with 32 bits, right? And so the overflow actually happens in hardware and produces the correct result. But it could happen in software as well. Okay, so this phenomenon does happen, right? And it's caused all sorts of, unfortunately, infamous events, right? And there's a not complete list right here. Right? Ariane 5 is the European Space Agency rocket. It's their current generation of rocket, I believe. Right? It's made in flight, right? So its first flight crashed shortly after takeoff. Right? It was loaded up with a bunch of satellites. It ended up costing $370 million. Right? Why did it happen? Well, it turns out there was a lot of reasons why it happened, but one of the reasons that it happened was right there. Right? There was actually an integer overflow bug that happened in its computing software that caused the inertial guidance system of the rocket to shut down. If you shut down the inertial guidance system of a rocket, it falls out of the air, right? And that's exactly what happened, right? Very embarrassing for the European Space Agency, cost them a lot of money, right? Fortunately, no one was killed in that particular event. What else here? Deep Impact was a NASA mission to land a satellite, well, not land, to crash a satellite or a probe onto an asteroid. That also ultimately ended up failing because of integer overflow. Therac 25 is a Canadian story. It ended up killing several people. It's a medical device. It had many problems with it. One of them was integer overflow. Your GPS system, everybody uses GPS, it's on your phone. Every 1,024 weeks, there's an integer overflow problem with GPS. Right? So in GPS, the GPS broadcasts the current time. Right? One of the pieces of information it broadcasts is the current week number. It only counts up to 1,023 for the number of weeks. So if you hit week 1024, it wraps around back to week 0. So roughly every 20 years, there is an integer overflow problem that happens with GPS. Year 2000, you guys missed it, you weren't born yet, right? But the year 2000 problem was a very famous and very expensive problem that occurred in the year 2000, right? And so prior to the year 2000, well, I guess prior to the 90s, the way that a lot of software would store a date, it would only store 2 years for the date. So 1998 would be stored as 98, right? This is obviously a problem when you hit the year 2000, because when you roll over from 99 to 00 to 2000, your date is now 00. And software doesn't know whether that is 1900 or 2000, right? That's a big problem if you're representing the age of a person, for example, right? Suddenly someone is either 100 years older than they should be or 100 years less than they should be, right? If you're paying out interest on some sort of investment, that's also a huge problem, right? You're either paying out 100 years too much interest or 100 years not enough interest, right? And so a huge effort went into solving this problem. People made lots and lots of money fixing this problem, including someone in our Department of Computer Science who's now retired. How much did this cost to fix worldwide? No one actually knows. It's estimated, though, that roughly $300 billion was spent fixing software to deal with this problem, right? The exact same problem is going to happen in 2038 for other reasons, right? So the year 2038 problem is same as the year 2000 problem, right? It has to do with how time is represented on most computers, right? So this happens in real life. It is an issue. All right. So what about double? So if you want to do floating point, so math that it looks like, so you want to do arithmetic that looks like real arithmetic in mathematics, right? Normally you choose double as your type, right? So this is slightly confusing if you come from Python and if you happen to know that the Python type is float, right? The type called float in Python is exactly the same, for most cases, exactly the same as the type called double in Java. The type called float in Java is not the type called float in Python, right? So float is the smaller version of double in Java, right? Okay, so there is a max, so it's the same issue, right? You have a fixed amount of memory to hold a double value. That means there must be some minimum and maximum value, right? So the maximum value for double is stored as double.max value. It's very big. It's roughly 10 to the power 308, right, which is unfathomably big for most people. The minimum value is not double min value, confusingly, right? The minimum value, the most negative value, is just the negative of the maximum value, right? Double min value is the smallest positive value, right? So it's the value that's greater than 0, or it's the smallest value that's greater than 0. In Java. If you write down a number that has a decimal point in it, Java thinks that that's a double, right? If you want a float literal, you put an F after it, right? So 1.0F would be a float literal, right? Float's just the smaller version of double. Right? If you try to write down a number that's outside the range of double, then the compiler will not compile your code, right? It'll say, hey, that's a mistake, you can't do that. Right? You can put in underscores in the number if you want to. Right? If you know what scientific notation is, you can also use scientific notation. Right? So that's 1,000,000.99. This is also 1,000,000.99. Right? And so scientific notation, it's some floating point number, followed by an e, followed by an integer number. The e just means times 10. And then the number after is the exponent, right? So that's 1 point something times 10 to the power 6, right? That integer can be negative, but it has to be an integer, right? So you can't raise it to 10 to the 6.5, for example. That's not allowed. Just like with int and long and any other integer type, that's not exactly true. Just like with int and long, if you perform an arithmetic operation with 2 double values, you always get back a double value, right? So in this particular example, these work the way you expect them to, right? Everything here is a double. So when you take x divided by y, right, 1 divided by 3, you get 0.333333, right? Or you get something that looks like 0.333333, right? When you take 13 and divide it by 3, you get something that looks like 4.33333. Okay, floating point values do not, they do not wrap around, right? So if you perform a calculation with a floating point value, you do not get overflow, right? So if it doesn't fit inside the range of the floating point value, there's no overflow. Floating point values saturate, right? So if you try to compute a value that's larger than double max value, you end up at double positive infinity, right? If you try to compute a value that's less than the negative of double max value, you end up at double negative infinity, right? So for example, if I take 10 to the 200 and multiply it by 10 to the 200, right? That's 10 to the 400, that's outside the range of double. That ends up as positive infinity, right? On the other end, you end up at negative infinity, right? So there's no wraparound with floating point, it's saturation instead, right? The doubles work exactly the same as floating point arithmetic works in Python, right? And so later on, so probably in a week or so, I am actually going to tell you not exactly. I'm going to tell you, I'm going to introduce you to how floating point numbers are actually represented on the computer. It's done the same way in both Python and Java. Okay, so functions. Python has user-defined functions, you all know this, right? Functions just some procedure that you can reuse, right? It's got a name, right? You can reuse the name, you can reuse the function just by calling the function. Right, you pass it some values and it may or may not return a value, right? So in Python, I can cook up this function called max2, right? It computes the max of A and B, right? It does so in a very strange way, right? So the way I compute it here is I compute A plus B plus the absolute value of A minus B, right? I claim that that's actually twice the maximum value, right? So whichever is larger, A or B, I claim that twice max is 2 times the larger of those two values. So if I want the maximum of A and B, I can just divide by 2, right? So my claim is that mathematically this is true, right? I will leave you, for the time being, to puzzle out why this is true. If you want to know, you can come ask me about it, right? Now, you can put this somewhere in a Python source code file somewhere, right? So you can put it into a module. Somewhere else, right, in some other Python source code file, you can import the module, right, and then call max2 like that. Oh, hey, I'm not going to leave you to puzzle it out. There's a picture here. I didn't realize this picture was here. This explains why this works. Okay, so what's A plus B? So here's A, and here's B, right? Now I don't know which one. So imagine this is the real number line, right? So if B happens to be the largest value, then B is over here. If A happens to be the largest value, then it's over here, right? The value exactly halfway between A and B is just the average. So that's A plus B divided by 2, right? What's the distance between A and B? Well, that's just A minus B take its absolute value, right? So if I'm here, how do I get to here, right? So I don't know what here is, right? But I know how to get to here. I know how to get to the minimum value. I know how to get to the middle, right? I know the middle is just A plus B divided by 2, so I can get to here, right? If I'm here, how do I get to here? Well, I can just take that value divided by 2 and add it to whatever this value is, right? So A plus B divided by 2 plus the absolute value of A minus B divided by 2, right? That's just A plus B plus the absolute value of A minus B all divided by 2, which is that, right? So that's why that works. Why am I doing it this way instead of using an if statement? Because I want to use some arithmetic and I want to blow this up when I do it in Java, right? Okay, Java's got no functions, right? Which seems like a strange statement, right? Instead, it has something called methods. So Java does have things that look like functions. They're called methods in Java, right? If you want something that looks like a Python function, the closest that you have in Java is something called a public static method, right? A method's just a function, except that you need a class to call the method, or you need an object to call the method, methods in Java are always found inside of classes, right? So notice in Python, right, you can stick this definition anywhere you want, right? And that will define the Python function. In Java, when you make a method, it must go into a class of some kind, right? So to create the equivalent method in Java, I have to make a class, right? So I'm just going to call that lecture 2, right? Inside the class, I can place the method, right? And so for the time being, when you create the method, it's always public static and then some stuff. Fortunately, the max2 int ab looks basically the same as it looks in Python. Right, so I'm going to explain what all this stuff does as we go through these slides. Right? Okay, so remember, methods, they always live inside of a class. Right? Now to call max2, right, if I'm calling max2 from a different class that the method is in, and that class is what's inside is inside of what's called a different package. I'll explain that in a second. You have to import the class, right? So if I have a different class called test lecture 2, right? I have to import the class that I want to use, right? I want to call the method max2. Max2 lives inside lecture 2. I have to import that class, right? When I call the method, right, I use the class name in front of the method name, right? So I can't just write max2 5 comma minus 3. So let me explain what's going on in Eclipse instead, because from the lecture slides, it's not so obvious what's happening. Okay, so here's lecture 2, right? Here's my method max2, right? Let me delete this for a second here. Okay, so there is a very simple Java class. It's not a complete program, right? Why is it not a complete program? There's no main method, so you can't run this thing, right? To run a Java program, the Java program must start at some main method. There isn't one here. So I can't, so running this thing doesn't work. What I can do though is that I can make some other class. Right? So I've got some other class called test lecture 2. Right? I would like to call the max2 method that's in the lecture 2 class. Right? Now this is a little bit different than what's on the slides. So let me back up to lecture 2. Okay. So lecture 2, the class lecture 2 is inside of what's called a package, right? So that thing that I've just highlighted over here on the left-hand side, right? That thing there is called little l lecture 2, right? That's a package. Packages are Java's way of organizing your source code files for your program into different places, right? So somewhere on my computer, somewhere on my hard disk, there is a folder or a directory, if you know what a directory is, right, called lecture 2, right? Inside that directory is the file lecture2.java, right? So let me show you what I mean by that. All right, so if I click on lecture2.java, right, I would like to know exactly where is this file on my computer, right? So if you go up to the File menu, right, down here there's a Properties button, right? So if I click Properties, it tells me that that file lecture 2 is here on my computer, right? This works if you're on a Mac or in Windows, right? If you click that little button there, it opens up your operating system file explorer and takes you to that directory or that folder, right? And so there's your lecture2.java. Right? If I go up one directory, right, you can see that there is, might be hard for you to read, but there is a folder called lecture 2. Right? That corresponds to the package lecture 2. Right? Get rid of this. Right? Now my other class, test lecture 2, is actually that class right there, test lecture 2. It's inside this package, some.other.package. Right? So some.other.package is actually 3 different packages. Right? So let me show you what I mean by that. So there's the lecture 2 package. There's the package sum, right? If I click on sum, you'll see inside there's the package other, right? And inside there's the package pkg. And inside there, you will finally find test lecture 2.java, right? And so the package mechanism in Java lets you organize your source code into multiple different folders belonging to your project. right? And so for small programs, this isn't useful, right? But if you have a large program consisting of hundreds or thousands of classes, you're going to want some way to organize those classes in some sensible way, right? The package mechanism is what Java uses to do so. Okay, so I'm inside of a different package, which is what that first line is telling you, right? That first line says that you're in the package some other package, right? I would like to call max2 belonging to the class lecture2. I have to import that class, right? So I need to import little l lecture2.lecture2. When I call the method, I need to use the class name in front of the method, right? And when you run this, right, that produces the number 5, which is good because 5 is the maximum of 5 and minus 3. Right? Okay, if you're back in lecture 2, though, everything I told you doesn't apply anymore. Right? So if I put a main method here, public static all right, so I'm now inside the lecture 2 class. I would like to call the method max2, right? You don't have to do anything special here. You just call max2, right? So int x, I guess, equals max2, and then 5 and minus 3, right? And everything's fine, right? If I want to print out the value, I can print out the value. Oops, sorry. X, right? So call the method, print out the value, and that runs now just fine, right? Why does it run? Because there's a main method. Right? How do I call the method? Well, I just call the method like I would call a function in Java. In Python. Okay, so no functions in Java. They're called methods instead. Methods look like functions. They live inside classes. Right? Yeah, I'm going to keep on going for a couple of slides, and then we'll call it quits. All right, so in Python, notice that your Java program here, there's a bunch of indentation going on, right? Now the indentation, it turns out, is not actually critical. So in Python, though, it's a completely different story, right? In Python, indentation is fundamental to the language, right? You must indent, and your indentation has to be consistent in Python, right? Otherwise, your program either doesn't run or it does not run the way you want it to. Right? And so the body of max2 is indented over one level, right, in Python. So in Java, the indentation, the compiler does not care about indentation, right? So indentation in Java is used only for readability, right? So in other words, only humans care about indentation in Java. Compiler doesn't care, right? You can easily prove this to yourself, right? Just go into a Java program and start deleting your indentations, or, right, for fun, mess up the indentation completely, right? Compiler doesn't care. It will happily compile this and run it, right? The only one who cares are people, right? And in particular, your TAs will care, and I will care when I'm if we're marking your assignment work, right? So if you mess up the indentation on your in your Java code. And it's easy to do, right? You accidentally delete something or you insert some extra spaces or something like that, right? Don't fix it manually, right? Whatever you do, don't fix it manually, okay? Go into the source menu, right? Look for format, Shift-Control-F or Shift-Command-F on Mac. Press that and it fixes everything for you, right? It fixes up your spacing, it fixes up everything, right? So before you hand in your work, use Eclipse, reformat your code, everything's good. If you're not using Eclipse, good luck, right? Sorry, there was a question.
Yeah, I was just asking, if it was broken up by a semicolon, could you squish it all onto one line?
Sorry?
Like, could you take what's in that function static in, take the return, put it up a line, but, like, and would it still work?
Yes. Yeah. Absolutely.